Students, it is practically not possible for a body to move with uniform velocity. The velocity of an object changes either by increase or decrease of speed, or by a change of direction. The velocity also changes when both direction and speed change. Whenever velocity of an object changes with respect to time, it is said to have acceleration. Acceleration is defined as the rate of change of velocity with time. Now, let a body moves from initial velocity u. It travels for t seconds and gains next velocity or the final velocity v. Then, change in velocity is equal to final velocity minus initial velocity, or rate of change of velocity will be equal to final velocity minus initial velocity divided by time. Therefore, acceleration, which is denoted by a, is given by final velocity minus initial velocity divided by time elapsed, or a is equal to v minus u divided by t, where a stands for acceleration, v stands for final velocity, u stands for initial velocity, and t stands for time elapsed. And the unit of measurement of acceleration here is meter per second. Students, let this be equation number 1. Students, let a body move from rest. Its initial velocity is equal to u. It travels for t seconds and acquires a velocity v. When the velocity changes from u to v, its acceleration is increased by a and covers a distance s. Now, by the definition of acceleration, we have acceleration is equal to rate of change of velocity. That is, change in velocity divided by time taken for the change. Or we can write a is equal to v minus u divided by t. Now, applying the rule of cross multiplication, we can write this relation as v minus u is equal to at, or v is equal to u plus at. Students, let this be equation number 2. We know that average velocity a is the arithmetic mean of the initial and final velocities. Therefore, average velocity is equal to initial velocity plus final velocity divided by 2. We can write this symbolically as u plus v divided by 2. Now, let this be equation 3. Students, but we know that distance covered by a body is equal to average velocity into time taken, or we write it as s is equal to u plus v divided by 2 into t. We can write this as u plus at divided by 2 multiplied by t, since v is equal to u plus at as given in equation 2. Now, we can write this equation as 2u plus at divided by 2 into t. Now, let us multiply the numerator by t, and we get 2ut plus at square divided by 2. Or this is equal to ut plus 1 by 2 into at square. Therefore, s is equal to ut plus 1 by 2 at square. Now, let this be equation 4. Students, we have v is equal to u plus at. Squaring both the sides, we get v square is equal to u plus at whole square. Now, let us expand this relation, and we write v square is equal to u square plus 2uat plus at whole square. Students, in the above equation, u plus at whole square is in the form a plus b whole square. So we employ the formula of a plus b whole square as a square plus 2ab plus b square. So we get v square is equal to u square plus 2uat plus at whole square. We can write this as v square equals to u square, and taking 2a common from the two terms, we write plus 2a in brackets ut plus 1 by 2 at square, or v square is equal to u square plus 2as, since s is equal to ut plus 1 by 2 at square as in equation 4. Therefore, v square minus u square is equal to 2as. When a body is falling freely under the action of gravity g from a height h, the above equations take the form v is equal to u plus gt, that is equation 6, h is equal to ut plus 1 by 2 gt square, that is equation 7, and v square minus u square equals twice gh, that is equation 8. Here we write h instead of s and g instead of a. Students, when a body is falling freely under the action of gravity, the value of g is positive. If a body is thrown up vertically, g is negative. G has the following values. G is equal to 9.8 meter per second square, or for a body falling freely under the action of gravity, the value of g is equal to 980 centimeter per second square. Now let us look at some examples. In the first example, the problem says a car accelerates uniformly from rest to 60 meter per second in 30 seconds. What is its acceleration and how far does it go within this time? Students, look at the solution. Here we have v is equal to u plus at. Now the final velocity is 60. The initial velocity is 0 since the body starts from rest. The value of a is to be calculated and the time given is 30 seconds. So we write 60 is equal to 0 plus a into 30, or 30a is equal to 60. Hence the value of a is equal to 2 meter per second square. Again, we have the relation s is equal to ut plus 1 by 2 at square to calculate the distance traveled by the car. So we write s is equal to 0 into 30 plus 1 by 2 into 2 into 30 square. This gives us s is equal to 0 plus 900. Hence, the value of s is 900 meter. Now look at the other example. It says, a train traveling at 112 km per hour slows down to 22 km per hour with a uniform retardation of 5 meter per second square. How long does it take to do so? And what distance does it cover within this time? Students, we have been given the initial velocity as 112 km per hour. Let us convert it into meter per second. So we write 1,12,000 divided by 3,600 meter per second, which gives us 1,120 divided by 36 meter per second. Similarly, the final velocity is given as 22 km per hour. Converting it into meter per second, we write 22,000 divided by 3,600 meter per second equals 220 by 36 meter per second. Since v is equal to u plus 80, substituting these values in this equation, we can calculate the value of t. So we write 220 by 36 equals 1,120 by 36 minus 5t. Or 5t is equal to 1,120 by 36 minus 220 by 36, or 5t is equal to 900 by 36. Hence, t is equal to 25 by 5, which gives us 5 seconds. Again, we have the formula S is equal to ut plus 1 by 2 at square. Now let us calculate the value of S. So we can write 1220 by 36 into 5 plus 1 by 2 into minus 5 into 5 square. This is equal to 1400 by 9 minus 125 by 2. Now let us take the LCM. And we write 2800 minus 1125 divided by 18. This gives us 1675 divided by 18, which is equal to 93.1 meter. Therefore, the train travels 93.1 meter in 5 seconds. Now here's yet another example. The question says, a body accelerates uniformly from 12 meter per second to 16 meter per second while covering a distance of 70 meter. Calculate, number 1, its uniform acceleration, number 2, the time taken, and number 3, the distance covered in the last second of its journey. Here is the solution. Students, we have the formula v square equals u square plus 2as. Now, the value of v is 16, u is 12, and s is 70. Now we can calculate the value of a using this relation. So we write 16 square is equal to 12 square plus 2 into a into 70, or 256 is equal to 144 plus 140a, or 140a is equal to 112. Hence, a is equal to 112 by 140, which is equal to 0.8 meter per second square. Therefore, its uniform acceleration is 0.8 meter per second square. Now again, we have v is equal to u plus at. We write 16 is equal to 12 plus 0.8 plus 0.8 into t, or 0.8t is equal to 4. Hence, t is equal to 4 divided by 0.8, that is 40 by 8, which gives us 5 seconds. Now let us calculate the distance covered in the last second of its journey. Students, we know that distance covered in 5 seconds is equal to ut plus half at square. This is equal to 12 into 5 plus half into 0.8 into 5 square. That is equal to 60 plus 10, which is equal to 70 meter. Now the distance covered in 4 seconds is equal to ut plus half at square. Here, t is equal to 4. So we write 12 into 4 plus half into 0.8 into 4 square. This is equal to 48 plus 6.4. That gives us 54.4 meter. Now the distance covered in the 5th second can be calculated by distance covered in first 5 seconds minus distance covered in the first 4 seconds. That is equal to 70 minus 54.4 meter, which is 15.6 meters. Students, the distance covered by the body in the last second of the journey is 15.6 meter. Now look at this example. It says a man throws a ball up to a height of 4.9 meter and catches it again. With what velocity does it leave his hand, and how long is it in the air? Now look at the solution. Here we use the relation v square equals u square plus 2gh. Students, we have been given the value of v as 0, g as minus 9.8, and the height is equal to 4.9. Now using this relation, let us calculate the value of u. So we write 0 is equal to u square plus 2 into minus 9.8 into 4.9, or u square is equal to 2 into 9.8 into 4.9, which gives us 9.8 into 9.8. Now taking the square root, we get the value u is equal to 9.8 meter per second. Therefore, it lifts his hand with a velocity of 9.8 meter per second. Now since we have v is equal to u plus gt, v is 0, u is 9.8, g is minus 9.8. Now using this relation, let us calculate the time. So we write 0 is equal to 9.8 plus minus 9.8 into t, or 9.8t is equal to 9.8. Therefore, t is equal to 1 second. Therefore, it takes 1 second to rise to its greatest height, and therefore, it takes 1 second to fall back to its starting point as well. So it is in the air for 2 seconds. Now the next example says, a stone is flung down from the top of a cliff with a velocity of 6.3 meter per second, and it reaches the bottom in 3 seconds. How high is the cliff, and with what velocity does the stone hit the ground? Students, look at the solution. We have the formula S is equal to ut plus half gt square. Now, the value of u is 6.3, the time is 3 seconds, g is 9.8 meter per second. Now, let us calculate the value of s using this relation. So, we write 6.3 into 3 plus half into 9.8 into 3 square. This gives us 18.9 plus 44.1, which is equal to 63 meters. Now to calculate the final velocity, we use the equation v is equal to u plus gt. That is equal to 6.3 plus 9.8 into 3. Which gives us the answer 35.7 meter per second. Now look at this example. The problem is, a stone is thrown upwards with a velocity of 39.2 meter per second. How high will it rise? How long will it take to reach its greatest height? How high is it 3 seconds after it is thrown? How many seconds later will it be at the same position? Students, now let us solve for these step by step. First, let us calculate the value of h. By using the relation v square equals u square plus twice gh. Here, we know that v is equal to 0, u is equal to 39.2 meter per second, g is equal to minus 9.8 meter per second. So we write 0 is equal to 39.2 square plus 2 into minus 9.8 into h, or 2 into 9.8 into h is equal to 39.2 whole square. Hence h is equal to 39.2 into 39.2 divided by 2 into 9.8, which gives us 78.4 meter. So it will rise to a height of 78.4 meter. Students, now to calculate the value of t, we use the equation v is equal to u plus gt. Let us substitute the given values and we write 0 is equal to 39.2 plus minus 9.8 into t, or 9.8t is equal to 39.2. Hence, t is equal to 39.2 divided by 9.8, which is 4 seconds. So, it will take 4 seconds to reach its greatest height. Now, let us calculate how high will it be in 3 seconds after it is thrown. We have the relation h is equal to ut plus half gt square, or h is equal to 39.2 into 3 plus half into minus 9.8 into 9. This gives us 117.6 minus 44.1, which is equal to 73.5 meter. Students, the stone will reach or rise at a height up to 78.4 meter. It will take 4 seconds for it to reach the greatest height, and in 3 seconds it will reach 73.5 meters after it is thrown.
Students, we discussed earlier about acceleration. Now let us have some discussion on retardation, or the negative acceleration. As you know, the rate of change of velocity is known as acceleration. Being a vector quantity, acceleration may be positive or negative. When the velocity of a body is increasing with time, it is said to have a positive acceleration, or simply acceleration. Sometimes the velocity of a body decreases with time. When the driver of a moving car applies the brakes, the car does not stop suddenly. Its velocity decreases gradually and finally falls to zero. At that instance, the car stops or comes to a rest. In this condition, the car has a negative acceleration. When the car is going to stop, we don't say that the car is accelerating. Rather, we use the terms retardation to explain its rate of decrease in velocity. We often say the car is retarding. Negative acceleration or retardation is the opposite to the direction of the velocity. When you throw a ball vertically upwards into the sky, its velocity goes on decreasing while it is rising. The ball is said to be retarding as it has a negative acceleration. Can you say what is the direction of its acceleration? Negative acceleration is opposite to the direction of velocity. Since the direction of ball's velocity is upwards, its acceleration will be in the downward direction. Students, we can conclude that if the velocity of the body is decreasing with respect to time, the acceleration is said to be negative. The negative acceleration is also called retardation.